All, let's start with chapter number 5, periodic classification of elements. So today I would be covering 3 marks question of it. So question 1 says the atomic number of sodium and magnesium are 11 and 12 respectively, and they belong to the same period. Which one should have smaller atomic size? So as you know, we have Na as 11. That means it can be written as 2 comma 8 comma 1, and magnesium can be written as 2 comma 8 comma 2. So therefore the magnesium will have smaller size, as it says which one should have smaller atomic size. The one with more atomic number will have smaller atomic size. So for the answer for first one is magnesium. Second is which one would be more electropositive? Na will be electropositive, as you know. Na is more electropositive, as you know, it forms plus 1 ions. And then 3, to which group would each one belong? It is Na. Na belongs to group 1. Why? Because we have one one electron in the end, so group 1 for sodium, and group 2 for magnesium, as the outer shell has 2. So magnesium has group 2. Now moving on to question number 2. It says explain the basic characters of oxides of elements down the group across the period. So basic character of oxides down the group increases. Why? Because metallic character increases. So basic character of oxides increases. Why? Because metallic character increases. Now, the second one, across the period. So, basic character of oxides decreases in this case. Why? Because along the period from left to right, because non-metallic character increases and metallic character decreases. Therefore, the basic character of oxides across the period decreases. So, basic character of oxides decreases as non-metallic character increases. Now moving on to question number 3, it says how many groups and period are there in modern periodic table? So in modern periodic table, groups are 18 and period are 7. Now second question, it says how do the atomic size and metallic character of elements vary as we move down a group? So first of all, valency first increases and then decreases. So there is a normal pattern of it. So always remember that valency first increases and then decreases. Therefore, the metallic character decreases along a period from left to right. So remember, valency, you can write down if you want to, first increases and then decreases along a period from left to right. Therefore, the metallic character also decreases. Now, we need to talk about atomic size. So, as you know, there is no change in valency down the group. There won't be any change down the group in valency. So, therefore, you can write that atomic size increases down the group, as there is no change in valency down the group. So, therefore, the atomic size increases down the group. Two elements P and Q belong to the same period of the modern periodic table and are in group 1 and group 2 respectively. So it is given that they are from group 1 and group 2. Compare their following characteristics in tabular form. So first is the number of electrons in their atoms. So P, as it is from group 1, should have one valence electron. Now for the second one, Q, it should have two valence electron, as it is from group 2, remember. And the second one, size of their atom. So P is bigger than Q. Why? Because it depends on the number of electrons we have. So as P has less number of electrons in the outermost shell, so therefore less binding will be there. So therefore P has a smaller size. Sorry, P has a bigger size than Q. So the C1, their metallic character. P is more metallic as compared to Q. Now D part, their tendency to lose electrons. So P can lose electrons more easily than Q, as it has less binding. So P can lose electrons more easily than Q. Now the next one, it says we need to write the formula of their oxides. So as we know that P has one valency, so I will write P at the bottom, and we have to combine it with oxygen. So it has 2 here, so it will be P2O, and for Q it will be Q, and the valence electron is 2. For O it is again 2, so they will cancel out and they will form QO and P2O. Then next is with the formula of their chlorides. So let's make formula of their chlorides. So let's write PCl. So P has one electron and Cl has again one electron. So it will be PCl. For Q has two valence electron and Cl has one. So it will be QCl2. This is their formula with their chlorides. Let's do next one. 5. It says, taking example of an element of atomic number 16, explain how the electronic configuration of the atom of an element relates to its position in the modern periodic table, and how valency of an element is calculated on the basis of its atomic number. So let's calculate this. So as you know, sulfur is actually 16, so we can write the electronic configuration of it first of all. So it will be 2, 8, 6. Now we need to find group number. So to find group number, you have to write the valence electrons. Valence electrons are the outermost shell. So valence electrons plus 10. So 6 plus 10 equals 16. Now we need to find period. So how to find period? Period number is equals number of shells. So the number of shells here are 3, K, L and M. So the group number is 16 and the period is 3. Then we need to find the atomic number on the basis of element's atomic number. So as you can see in the last group, in the last shell we have 6 electrons. So 8 minus 6 is 2. So therefore the valency of this element is 2 electrons. So 2 valence electrons are present in this atom. Now moving on to next question, it says we have 4 different elements: hydrogen, beryllium, and we have sodium, and we have magnesium. So write the pair of elements having similar chemical properties. So here, as you can see, the valency for H is 1 valence electron is there, and valency for sodium is 1 as well. So therefore they have same chemical properties. And the other two group, beryllium has again 2 valence electron and magnesium has 2 valence electron, so therefore they have same chemical properties. Now we need to state the group number of each pair. So beryllium and magnesium belongs to group 2, and hydrogen and sodium belongs to group 1 as their valence electron is 1. So moving on to C part, it says name one another element belonging to each of these group. So for beryllium and magnesium we can write calcium from group 2, and from one group you can write potassium, that is K, from group 1. So that's your answer for this one. Next question is three elements X, Y, and Z have atomic numbers 7, 8, and 9. So let's write the atomic number for X, Y, and Z. So X is 7, Y is 8, and Z is 9. Now first of all I will write the electronic configuration for all. So for first it is 2 comma 5, for 8 it is 2 comma 6, for the last one it will be 2 comma 7. Now we need to state their position in the modern periodic table. So for X, if we need to find group number, we have to add 10 to the last shell, that is 5 we have in this. That means valence electrons. So 10 plus 5 is 15. Now for Y, it will be 10 plus 6, that means the group number for Y is 16. For Z, 10 plus 7, that means the group number is 70. Now we need to find period for all. So the period for all will be, as you can see, they have two shells each. So the period will be second in each case. Now in the B part, we have to arrange these elements in decreasing order of their atomic radii. So let's arrange them. So X will be the greatest one, then Y, then Z. Then we have to write the formula of the compound formed when X combines with Z. That means we have to combine X with Z. So Z has a valency of 1 and X has a valency of 3. 8 minus 5 is 3. Now taking reciprocal, so it will be X Z3. So this will be the formula of the compound formed when X combines with Z. Start with next question. So it says name the element with atomic number 19, in which group it is placed. To which period does it belong to? Write its electronic configuration. So for answering the above, we need to write the electronic configuration. So electronic configuration will be 2, 8, 8, 1. Now we need to state in which group it is placed. So the last number suggests the group number, so it will be 1. Now the period. Period means number of shells the element has. So here it has 4 shells. So that means the period will be 4. Now moving on to next. It says why is atomic number considered to be more appropriate parameter than atomic mass for the classification of elements in a periodic table, and how does the metallic character of elements vary as we move from left to right in a period and top to bottom in a group of the modern periodic table. Give reason to justify your answer. So first answer, that is why is atomic number considered to be more appropriate, is because their chemical properties depend on the number of valence electrons, which is determined with the help of atomic number. So you can write the answer if you want to. So it is because chemical properties depend upon the number of valence electrons. Now we need to state how does the metallic character of elements vary as we move from left to right. So metallic character decreases from left to right because atomic size decreases, tendency to lose electrons decreases. Therefore, the metallic character when we move from left to right in a period decrease down. You can write because atomic size decreases. Now B part, it says top to bottom in a group of the modern periodic table. So when we move from top to down, the metallic character increases. Why? Because atomic size increases, due to which effective nuclear charge here decreases. So you can write that metallic character increases because atomic size increases. Now moving on to next question. It says an element X belongs to third period and group 16 of the modern periodic table. Determine the number of valence electron in the valency of X. Molecular formula of the compound when X reacts with hydrogen. Write its electron dot structure. Name the element X and state whether it is metallic or non-metallic. So first of all, let us write. It says X belongs to third group and it says that group is 16. So it suggests that it has last number of electrons, number of valence electrons be 6. So therefore 286. Now you can write, as you know, for 16 it is sulfur. So that means the element X is sulfur here. Now we need to determine the valence electrons and the valency of X. So valence electrons are 6. That means the number of electrons present in outermost shell. So here outermost shell is 6 and valency is equal to 8 minus 6, that is 2. So valency here is 2. Now we need to make a molecular formula of a compound X when it reacts with hydrogen. So that means H is 2. Sorry, H is 1. The valency of H is 1 and S is 2. So it will be H2S. Now we need to form the molecular formula. That means we have to represent it with electron dot structure. So in between I will take S and in corner I will take 2H. So S has 6 valence electrons. One less and one from H, one from H. So this is the structure of H2S. Now we have to name the element. Element is sulfur and we have to state whether it is metallic or non-metallic. So it is non-metal as it is present in 16th group. So it is a non-metal we have, and that's the end for this video. So these are 3 markers, important questions, so must do them because these are the repeated questions of the last year. So that's all for this video. Have a great day. We'll meet you in the next video.